Good afternoon and welcome to the AUC Data Science Seminar Series, DS Cubed.
I'm Talitha Washington, and I'm the director of the Data Science Initiative. And we welcome you today to today's seminar. Before we get started, I'm just going to talk a little bit about the Atlanta University Center Data Science Initiative. So the Atlanta University Center Data Science Initiative is between a consortium across 4 institutions: Clark-Atlanta University, Spelman College, Morehouse School of Medicine, and Morehouse College. We are HBCUs situated in downtown Atlanta, and we are super excited about engaging with our other HBCU friends at Bowie and Fisk. And we also have our colleague from Morehouse School of Medicine today. So the initiative has 2 goals. The first goal is to develop talent to be a significant producer of African Americans with expertise and credentials in data science, and to generate new knowledge to address race, gender, and social justice aspects of data science. So just a little bit about our curriculum work, about how we're building up our education, is that we're developing an AUC-wide data science minor that will be housed at our undergraduate degree granting institutions: Clark-Atlanta University, Morehouse College, and Spelman College. So we have an AUC-wide team that's made up of 3 from Clark-Atlanta, 3 from Morehouse, and 3 from Spelman. We also have a member from Morehouse School of Medicine and a member from the library to develop the data science minor framework that the institutions then will follow and flesh out for their respective schools. So the data science minor will prepare our students to obtain, process, analyze, and present complex data, including data related to the African diaspora, which coincides with our mission of being historically Black colleges and universities. We have identified 6 learning outcomes: mathematics and statistics, programming, modeling, data curation, ethics, and communication. And so our minor, we're going to have all of our students take an introductory course in data in the African diaspora, a math stat course, programming course, and then 3 electives. So we're really excited to hear from our friends to see how they're thinking about building programs. Before I turn it over, I just want to give everybody a heads up that next week on March 31st, that's Wednesday at 12 p.m., our awesome faculty engagement working group is having their March seminar on data visualization and the war on drugs. When I stop talking, I'll put a link in the chat, or if someone else can do it, that would be great. Also, just to save the date, on April 23rd, we are going to have our inaugural W.B. Du Bois Data Science Symposium. So W.B. Du Bois was a faculty member at Atlanta University and also pioneering data visualization. So save the date, Friday, April 23rd. It's going to be fun and it's going to be amazing. Just a heads up to our AUC faculty and staff, we have some funding opportunities for this summer in the way of mini grants that are due April 1st. So if you haven't yet get started, get going, because we would love to support your data science related research and curriculum development. So please join us. And we also have an affiliate program for AUC faculty and staff to join and be officially engaged with us. And if anybody else in the ecosystem would love to come down to the AUC, we have employment opportunities across the institutions. For Clark-Atlanta, we have a couple at Morehouse School of Medicine, as there, and Dr. Howard will talk about their programs there. We have some at Morehouse College and also Spelman College. So we are hiring across the AUC in data science and data science related positions. So now I just want to turn it over to our awesome speakers. So they're going to talk to us today about how to build a degree program in data science. So a lot of folks will come to me and say, well, how do I do this? I said, well, let me tap my friends on the shoulder and see if they would come and share from their perspectives on how to do it. And, it's a great conversation to have. So first up will be Dr. LaTanya Brown Robertson. She's a professor of economics at Bowie State University, and she earned her Bachelor of Arts, MA, and PhD in economics from Howard University. I used to be at Howard, so I still have an Howardite affiliation. She specializes in urban housing and applied economics. She's published in various peer-reviewed journals, from the American Economic Review and all these other fantastic journals. She's worked on funded grants. She has an NSF grant to infuse data science and analytics into the undergraduate curriculum at Bowie State. Bowie State has 16 credential programs, so they're really making a lot of headway about how to reinvigorate what it means to do data science education just in new ways. Our second speaker of today will be Dr. Sajid Hussain, who's the Associate Vice President for Innovation and Information Technology and Discipline Coordinator of Data Science at Fisk University. He joined Fisk in 2009 and as an associate professor in the Department of Math and Computer Science. He served as the chair of the Department of Business Administration, and prior to Fisk, he was an associate professor over at Arcadia University in Canada. So he's had a number of different hats in different disciplines. Really cool. And he received his PhD in electrical engineering from the University of Manitoba in Canada. He's interested in applying machine learning and techniques for interdisciplinary research projects related to healthcare, bioinformatics, digital humanities, and criminal justice. And we're really excited to have him here to share about what's happening at Fisk. Fisk is the first institution in the state of Tennessee to have a bachelor's program in data science. So we're really excited about that. Our third speaker will be Dr. Angelita Howard. She serves as the Assistant Dean for Online Education Expanded Programs and is an assistant professor at Morehouse School of Medicine, which is part of the AUC consortium. She's been an integral in the development and implementation of strategic plans in collaboration with academic staff for new and ongoing online program expansion, as well as program expansion for the Data Science Initiative. We have thoroughly enjoyed working with Dr. Howard. Her current research includes faculty teaching and learning, self-directed studies, and engagement in the biotech industries. She holds a BA in music, a master's degree in both education administration and teaching. She then earned a doctorate in education administration. She has a whole bunch of degrees and certificates. Wowzers. So in addition to the scholarly training associated with all of her many degrees, she has engaged in professional development related to online learning, assessment, and strategic planning, and student educational enhancement. So she is bringing the foresight, the vision to really reframe how are we going to do this online education from Morehouse School of Medicine and in new arenas such as health informatics, such as biotechnology. So we're really excited to hear from her. So with that said, I am going to turn it over to our first speaker, which is, if I could stop sharing, I don't know. Come on, button. Is LaTanya, would you like to take it away? Feel free to grab the screen.
Great. Thank you so much, Dr. Washington. Hello, everyone. My name is LaTanya Brown Robertson, and I'm a professor of economics at Bowie State University. Give me 1 second. I'm going to get my slides together to share them with you all. Okay. All right. I'm going to be there 1 second. Okay, great. I believe you all can see my slides. So let's begin. My name is LaTanya Brown Robertson. I'm a professor of economics at Bowie State University, and I'm also the lead for the Data Science and Analytics Initiative at Bowie State University. Before I begin, let me just tell you a little bit about Bowie State University. We're the first historically Black institution in the state of Maryland. We have about 23 undergraduate majors. We have 20 master's degree programs, 2 doctoral programs, and as Dr. Washington mentioned, we have 16 specialty certificates. I reside in the College of Business in the Accounting, Finance, and Economics department, where we have 9 concentrations underneath the business administration degree at Bowie State University. We currently have 2 certificates out of the College of Business and 4 graduate programs. One thing that's really important that I was happy to see is that when our new dean came on board, Dr. Lawrence McNeil, he really, we were already moving forward with data analytics. And so he was excited. That was one of the reasons why he wanted to come to Bowie State University. And he actually made data analytics one of the 4 pillars within our College of Business. So that was really exciting. So let me give you a little background on how we really got to the point where we started offering a concentration as well as beginning as almost towards the end of the process of having a certificate. So we received a National Science Foundation HBCU UP Targeted Infusion Grant in 2018. But prior to that, we began this whole process around in 2016 and 2017. I had the opportunity to do some research with the Washington, D.C. Governor and Chief Financial Officer, and I was doing research on their tax databases. And I started looking around and I started noticing some of the knowledge, skills, and abilities that the employees had, as well as some of the interns that came from other institutions had. And I took that information and basically went back to my co-PIs, Dr. Azina Zenabi and Dr. Ntembe, which is Dr. Zenabi is in information systems and Dr. Ntembe is an economist. And I went to them and I said, you know what? We're missing the boat on this. We need to do our research and really get to the point where our students are prepared for these skill sets. So that's how the grant came about. And within the data science and analytics initiative, our goal is to really infuse data science and analytics across the entire campus within the undergraduate courses, as well as to offer and integrate new courses, have undergraduate research opportunities, and more importantly, we decided to do all of this by establishing a faculty learning community. To kind of begin throughout our whole phases, we had about 3 stages, and I would say stage 1 was curriculum development. So we had to really, after doing research and development, we decided to develop an overall framework. So we wanted to understand, well, what are the competencies that are important for skill sets within data science and analytics? And so we discovered that math was definitely important, programming was important, statistics was important. And then we wanted to take it further to really understand what are these common knowledge, skills, and abilities that were needed. So we began to analyze existing programs. At the time, most of the programs were on the master's level. So we began to see which type of courses were offered within those programs. We went through a lot of job announcements for data scientists and analysts, and began to understand what type of competencies and skills, as well as degrees that they were looking for. We continuously surveyed the literature. We came across some really great research, including Dr. Washington's research. And we also read different reports by PricewaterhouseCoopers, the McKinsey Institute, and so forth. So all of those things were important. I really think another key thing that was really important during our foundational stage 1 period was for us to establish an advisory board with practitioners in the field within data science and analytics. We thought it was really important to have them in the beginning and to engage them throughout the process. Lastly, another thing that we did within stage 1 is that we knew data science and analytics was a multidisciplinary field. So we wanted to make sure that we identified all the disciplines that are across campus that were closely tied to or impacted by data science and analytics. So these things were really important within our stage 1 process. For stage 2, it really dealt with engagement and infusion. So this is where our faculty learning community really came into play. So we established this interdisciplinary faculty learning community where we meet once a month. We still meet once a month, second Tuesday from 2 p.m. to 3:30 p.m. And this goal was to increase faculty's knowledge within data science and analytics through online training as well as workshops. Next, the following step dealt with having workshops and module infusions after we created the modules. So let me backtrack for a minute. Once the faculty members were trained, we engaged the faculty members in the development of the modules, as well as in the development of the workshops. And then after that, we began to create the modules with the faculty learning community, as well as certain workshops within big data, data wrangling, data analytics, visualization, and machine learning. We use the faculty as agents to be a part of this whole process of developing the modules and the workshops that they would infuse in their courses. As of fall 2020, we infused about 5 different modules in about 15 different courses within multiple sections. And so far, we've impacted about 700 students. And that doesn't even touch on the undergraduate research that we've came out, which so far has warranted about 5 publications. For stage 3, during the module infusion process with the faculty learning community, as we met each month, we began to just figure out what our pain points and what our gaps were within the modules, as well as some of the gaps within data science and analytics that still existed. So this involved a continuous improvement process. At the same time, we were still looking at the research and the new updates that were coming out regarding knowledge, skills, and abilities from the industry and so forth. We also engaged an advisory board as well. Okay, so I'm going to quickly get to my other slides for our data analytics concentration within the College of Business. We have the students start off with 46 hours within the Gen Ed, and then they have 48 hours within the business core, and then they have 27 hours within the concentration, and these are the classes that are available. The fundamentals in data science and analytics is actually a course that we're putting through the Gen Ed community right now, the committee right now, and then the data science and analytics electives are not just within the business school, but can be within computer science, C-Tech, as well as bioinformatics. I'll quickly go through this one. This is our certificate program that we're proposing, which has 12 credits within the certificate program, as well as the foundational data science and analytics course. It's important that the students have math and statistics also as prerequisites. Stage 4 is the traditional process that you go through in most institutions, where we got internal, external stakeholder feedback, and then it was approved through our Higher Education Commission in fall 2020, and the courses begin in fall 2021, and the certificate is on its way to approval. Lastly, as far as lessons learned, I'll be quick about this, but I think it's important. Buy-in is important. Often having data proof of impact throughout the entire process. Education and dissemination of your work is definitely important. Having faculty members across campus to help you champion your program is definitely something that's needed, as well as having an advisory board from the beginning that can help you throughout the process. So thank you so very much. And I look forward to you all's questions.
Thank you so much, Dr. Brown. So now we're going to turn it over to Dr. Hussein, and feel free to put questions in the Q&A as we go along. Dr. Hussein?
Hi, yes, I will upload share my screen. Yeah, just give me a second. Can you see the screen now?
Yep, all good, thanks.
Okay, welcome everyone. So I will talk regarding our data science initiative at Fisk. So just jump into it. First of all, Fisk, as you know, is the oldest higher ed education in Nashville, Tennessee. And we are also the first one in Tennessee to launch the data science program in undergraduate. We have 3 options for the students. They can take a Bachelor of Science or Bachelor of Arts, or they can even do the minor in data science. So all these 3 programs are there. As our colleagues has mentioned, I'm just going in sequel to it. So jumping and what data science program is at Fisk. So here is I want to focus you on. First is the computational thinking. Of course, data science has some computing aspect in it. Second is the math and statistics. We have some quantitative aspect in it. And third thing, we also want to have some interdisciplinary work at Fisk. So students also take part in some partner discipline. That could be anyone actually. So these are the three prime, like a tripod, three main areas which really identifies and make data science quite different than the other computing majors. Focus is on data, but counting on our computational thinking, mathematics and statistics, and some application domain. And of course, we have capstone and research areas, as well as the traditional core requirement and foreign language. So total of 120 hours still. So the main difference between Bachelor of Science and Bachelor of Arts is the focus on the math and statistics as compared to focus on the partner discipline. So for our Bachelor of Arts majors, those who are coming from psychology, political science, history, they take fewer hours in math, and they take more hours in their own area. So next we also have, as I said, minor in data science, which is 20 to 24 hours. So it can be easily combined with any major on campus, and it is really popular at Fisk. Many students prefer it. It can be done within 2 academic years. So even if they are starting in junior year, they can still complete the minor by the time of the graduation. Here we have these 12 hours of basic computational thinking, statistical and math background, and some elective courses they can take, for example, mathematical modeling or machine learning. Now, how to make it happen? It sounds very interesting, but sometimes it is difficult to start with. So just give you the overall view. So of course we have to go through the approval process. First propose the major. We followed ACM guidelines by the famous paper where Dr. Washington is the co-author. We follow ACM curriculum guidelines for data science, prepare the proposal according to faculty handbook, approved by the department, goes to faculty assembly. Also it has to go to the board of trustees. So even in internal, it may take around 6 to 8 months, or you can say 1 academic year. And then afterwards, we are not done yet. It has to go through SAC, COC, or whatever your accreditation body is, because it would be a substantive change. So we have to go through this process. I highly recommend check with your SACs or your accreditation liaison a bit early, so you know that what will be coming next. And of course, finally, it has to go to the DOE as well. Actually, when we were at early stage at Department Faculty Assembly, we went ahead and we also prepared at the same time for the substantive change SAC COC requirement. So it really helped us. By the time it was approved internally, we were almost ready, set to go for the external review. Now, you don't need to start from the scratch. As you saw earlier, we have computer science and math courses, and they may already be available in your department. So it's not that you're starting from scratch and you have to create so many new courses. For example, programming, data structures, uh, database, machine learning. Most likely they will be available in your department. And similarly for the math courses as well. So they already exist, but it is not, but still there's a opportunity to some curriculum innovation, because you can't just plug and play. Sometimes we may need to revise courses more geared towards data science. I think that actually is an opportunity to write our NSF tip grant. As Dr. Brown mentioned, she got the NSF tip grant. You can apply for NSF use grants. So there are tons of opportunities which actually energize all of us. Interdisciplinary work and applying, getting the funding. So it really gets faculty excited and administration as well. So as, making the program is one thing, but we really need to make it happen. So we need to engage students. Holistic advising, I think, is a key pillar to really make sure that we launch exciting program and that students also benefit from it. So here is our link. We followed this major maps. Thanks to UNCF CPI grant, we got the funding, and we implemented these major maps. Here's a QR code if you want to go to that link directly. So in that, on this page, I just got the screenshots to save time. We have the advice for the courses, what courses to take, but sometimes we just stop at the courses. We also gave them the advice regarding what relevant experience will be beneficial in their program, like start planning for the internships. And sometimes students think I will apply internship when I'm junior or senior. On the other hand, in data science, earlier is better. And there are many companies who give internship even at the freshman year. And then, of course, you have to connect with the community, whether it is NASB or NC Wait or your other chapters, ACM chapters, IEEE. So really want to engage students around the community work. At the same times, we have to think globally as well. Of course, foreign languages are the requirement, but we can have more focus on our major, how our own major, our assignment projects, they align with the global perspective. And of course, get ready for life after graduation, so they know how to prepare for it. And finally, where students always wonder, where can I go after graduation? So we also say, yeah, you can go to the industry, you can go, these are specific titles, you can go for a research lab, or you can even go for the grad school. And that's it. It's a short and sweet. If you have any questions, feel free to send me email or ask questions now. Here is a link for my webpage as well. Thank you.
Awesome. Thank you so much, Dr. Hussain. And you can put questions in the chat and we'll get them at the end. And for now, we turn over to Dr. Howard.
Thank you so much. Good afternoon, everybody. Thank you. So glad to be here. And so I am at Morehouse School of Medicine. My name is Angelita Howard. I serve as the Assistant Dean for Online Education. The great thing about Morehouse School of Medicine, we are just building, in our third year, we are just building online programs. So it's really exciting. I'm excited to share about our journey and what we're doing. Currently, we have an Executive Master of Public Health that started in 2019. And then we have a Master of Science in Biotechnology that started also in 2019. So it's been an incredible journey. We are building our third online program, which will be a Master of Science in Health Informatics. And I'll really talk about that today. This is the information I'll share. So one of the first things as you're thinking about building a data science program is you think about your institution and why it's important for your institution. So we looked at, why is health informatics important for Morehouse School of Medicine? We talked about, what is health informatics? So this is where your internal body comes in. You've heard from my colleagues today already about advisory boards and our internal and external stakeholders, and I'll talk about that as well today. But we look at, why is it important for our institution? Because every institution shouldn't offer every program. We can't offer everything. It would be nice financially to be able to do so, to be the school that does everything, but you have to understand why it is important. And so because of our mission to help underserved, we are driven and purposeful in health equity. We know, and we are every day trying to make sure that our people, everybody understands what health equity is. And so this Health Informatics degree program that we built, we looked at those things. We looked at what the technology would bring, how it would improve health outcomes. And then right here, when we think about diversity in health informatics, African Americans make up less than 15% of allied health workers. And so we need to expand that pool. We need to make sure that we are growing, that we're increasing. Less than 3% executives are in the health informatics space. So this was an opportunity for, again, thinking about health equity and how do we diversify health informatics. Health informatics by 2022, there's going to be job rate increase to be 100 we are looking at $100 billion industry. So of course, we want to make sure that students get in this space, that they get in this area, and that they are equipped for the workplace. Well, who benefits? So you begin to think, again, you're talking to your external, your internal advisory, your external, your faculty, who will benefit from this Master of Science? So if we're building this data science program, who benefits? Where are some of the career areas? Clinical project manager, quality improvement. So you begin to think about that, because as you are equipping students who will come through your program, you've got to make sure that there's industry and that there is a place for them to go once they leave your program. So with our programs, what we've tried to do is to make sure that they are short in length. And so this program will be 14 months. And we also make sure that they're affordable. The Master of Science in Health Informatics is $33,500. The same as our Master of Science in Biotechnology. It's the same cost, $33,500, and it's 1 year, because what we found out and continue to see is that, especially with graduate programs, students are looking to go right into the workplace. So we want to make sure that during their time, while they're here at Morehouse School of Medicine, they're getting the knowledge they need, the skills they need, but they're also getting prepared for the workplace. So some of the key elements of data science curriculum, we're very, very purposeful when we look at data science curriculum. And again, that comes with talking to our internal stakeholders, our faculty, really understanding what students need. And so I won't go through all of these, but I kind of just highlighted some input, output systems, the database systems. What are the, especially when we think about health informatics, a lot of this is, a lot of informatics is thinking about or considering, and a poll just popped up. So hopefully you all are seeing that poll. But the database system, what type of system is used? What type of system? Cloud platforms, these are things that we will talk about. The students will get cloud, distributed, GPU, CPU, predictive modeling, classification, regression, and visualization. Again, because we want the skills and the knowledge that students gain, we want them to be able to go right into industry. And so one of the things that we have done at Morehouse School of Medicine, we have no problem using adjunct faculty. And the reason why we use adjunct faculty, especially in our online programs, is because they are industry, heavy related industry. And so we know that industry helps to inform how we build the curriculum. And we make sure that when we partner with our industry leaders, our faculty, that their expertise, they are practitioners, so that when students leave Morehouse School of Medicine, again, they are comfortable knowing that they have the education, but they also have the experience from experienced people who are in the field every day. And so we're building our curriculum. Our curriculum is very applied. For the biotechnology, it's heavily applied. And as well as the health informatics, it is very applied, because we want students, when they leave, that they're seeing, as soon as they walk into the workplace, they're not just seeing what they may have read in the textbook, but they're actually simulating ideas from which people are seeing every day. So you ask, well, what's the process? What is the process? And again, Doctors Brown and Hussein talked about this already, but there's this external advisory committee. So we build the external advisory committee by looking at taking, again, people from industry. Certainly we're asking people who are in the health informatics space. So for example, our health informatics industry partners, or our external advisory, consists of a former chief information technology officer, people who have worked, a data analyst, a vice president of compliance, and other people, someone in the med tech, a couple people in the med tech, health consultants. So we look at making sure that our external advisory committee is diverse, but with people, again, because it's very industry focused, that people who are in the industry, people who can make sure that we have scholarships, that's really important. People who can make sure that our students, when they leave, they have a place to go. They have either career development, mentorship, they have those things. We've built what's called a bridge to biotechnology. And also we built the bridge, a summer program that's called Bridge to Health Informatics. And during those, it's a 5-week summer program. And during those 5 weeks, students are exposed to either health informatics or biotechnology. But the faculty who facilitate in these bridge programs, again, they are practitioners who are helping our students. So some of them help give recommendations as to who could be on our external advisory committee. And then of course, once people who start being named, they have other colleagues that can help us. We also benchmark other schools. So of course you want your program to be to compete with other programs because at the end of the day, you want them to come to your school. You want them and what you offer to be industry competitive or organizational competitive. So we benchmark other schools to see what they're doing, how they're doing, why are they getting the ratings that they're getting, how they're getting the ratings that they're getting, what are their costs? If you have 10 schools that you're benchmarking and you're $40,000, $50,000 ahead of them or above them, then guess what? It's probably going to be where other students will come to go to the other programs because they can get the same education for less. Also, you're looking at things like their curriculum. You're looking at the time for completion. Again, we know that students at this level, they want to complete it and get it done. Curriculum development, again, that's been talked about. How do you develop your curriculum with your internal faculty, your external faculty, looking at best practices curriculum, and then on to accreditation. At the same time, while you're doing all of those things, you have the application process. So you've got to build your application. What do you want your students to, what should they know? What is some of the knowledge that they should gain, or the people that are coming in? What should they already have? Finance, looking at the tuition, the scholarships, financial aid, making sure, again, those things are aligned based on the school. And so you need to work with your business partners or your business office to make sure that the price that you have, the price point, it matches the type of students that you normally have. And then career services, that is huge, making sure that your career partners are there, they are aligned, so that when students are ready for internships or when they're ready to graduate, they have somewhere to go. You don't want to have programs where your students, they have no job. Now, I'm not saying that you have to make sure that 100% of your students have jobs, but you have to have seminars, webinars, career connections, network connections, career fairs, so that students can make sure that they're equipped for the workplace. And finally, when you kind of do all of that, then and think about that, your school gets to be #1 across the US in its program, as Morehouse School of Medicine is #1 through Intelligent Pick for the top master in biotechnology. So we're excited. It's only 3 years old, but it's #1. And I think a lot of things that our colleagues have already said today, certainly we ditto as to how to build a data science program. Thank you all so much.
Thank you so much, Dr. Howard and my fellow panelists. Right now, I'm going to turn the mic over to Bettina Gardner, who's the Administrative Director, and she is going to do a report out on the poll.
All right, good afternoon, everyone. Thank you so much for joining us, and thank you so much to our panelists for all of this, this informative session about how to build a data science program. So looking at our audience, we'd like to know who's tuning in and engaging with us. So it looks as though this time around, 90% of our audience are working professionals or people who have graduated. So welcome, welcome. It's great to see that we have some reach out into outside of our own college bubble. And then since we do have a few that are students, most of them are at the master's, 7% master's students, and then 3% or one person is a PhD student. But again, that 90% are not currently enrolled students. As has happened across the board, we've had generally a large split where it's been mostly female, and then we also have 40% male and 3% other in terms of gender. Where folks currently live. This is, I think, our first webinar where we've had more people from outside of Georgia joining us than before. So welcome all you non-Georgians. Thanks for tuning in. I'm sure a lot of that is attributed to all of our panelists that are from across the nation and at different HBCUs. So welcome. And we also have one person international. So if you guys from outside Georgia want to say in the chat your city and state, and country, since we do have some international tune in, please do drop that in the chat so we know where you're tuning in from. And then, are you involved in building a data science program? So 60% of the poll respondents are involved. So glad to see you guys here. And we hope that this has been very informative and useful as you move forward with your programs. And if yes, what disciplinaries does your data science program include? So at the top would be 40%, or 12 people said natural sciences and mathematics. And then right after that would be computer and information science. And then there's a few at social sciences with 7% and business and economics at 3%. The vast majority of folks that answer though are not currently involved with building a data science program. So this next question might be for you. Are you interested in enrolling in a data science program? So we have one person, which is looking at an undergraduate degree level program. So you've got at least 3-4 options here to look at. And then also we have 3 people interested in a master's degree level, 1 at the PhD level, and then 23%, seven people are interested in online certificates, badges, or certification programs, because we all are very busy. And if you're working professionals, we understand that. So thank you all for joining us. Thanks for completing the poll. And at the bottom of your screens, there's a Q&A button. Please submit your questions there, and the panelists will be able to answer you there. Thanks.
Thank you so much, Bettina, for the report out. All right, so we're just going to dive into the questions that people have placed into the Q&A. So Dr. Brown, the first question is for you. It says, how broad are the disciplines of the faculties that are in the faculty learning communities?
Okay, great. All right, well, I'm going to name a lot of these disciplines. So I'll start off with economics, finance, information systems, management. So those are the business disciplines. We also have people in psychology, criminal justice, biology. They're definitely, well, actually one of the co-PIs was in the biology department, and computer technology. So those are the members who've been involved. It's about 12 of us, and we're like a little family. So it's been a great experience with the learning community. I highly recommend it.
Oh, great, great. So Dr. Hussain, this next question is for you. Someone says, I've been at 2 institutions, an R1 and liberal arts, which are considering a data science major. While the computer science and statistics departments are quite enthusiastic, the mathematics departments were hesitant about being involved. I think the person asking is a mathematician. Can each of you say how you got buy-in in starting a data science major or minor from the mathematics departments?
Sure, I can share my experience. So, in a math department, some colleagues are more towards like a theoretical maths and others. And there are other colleagues who are more on the implementation, scientific computing and others. So it may be easier to check with those colleagues who are already excited about scientific computing because they're already programming in MATLAB or some other tool, who are working with, collaborating with engineering departments, working with partial differential equations, all that. So we have to identify colleagues who are already passionate about, whose research is a bit computation involved. So that would be easy start to work with these colleagues. So we did same thing in our math department. Some were more excited than the others. Second thing is incentive. What is a gain for math department? So if we bring computing and more funding and more resources, more students, more recruitment, it just brings more, freshness in the department. Another thing we did, as our other colleagues mentioned, have start early and faculty development workshops. Sometimes people don't know what data science is about and how maybe they did programming 20 years ago in C++, which was scary, or maybe in COBOL, Fortran. So they get the experience, like in these days, scripting language, Python, Show, Anaconda, even the graphs of Plotly, Dash. That is so engaging for everybody on campus. Just them the end product rather than showing all that programming details. This is what people can achieve it. And at our department, that was quite effective, showing the end product, Dash, other Plotly portfolio. Data visualization is always exciting. Yeah, thank you.
Thank you so much. Dr. Howard, this next question is for you. I think this is coming from an instructor at an HBCU. So a part of Morehouse School of Medicine's mission is to increase diversity of the health professional scientific workforce. And it also includes an emphasis on people of color and the underserved in both urban and rural populations in Georgia, the nation, and the world. So what are things that you all do to connect the health informatics program to this mission or to your students' experiences?
That's a great question. They sound like they came straight from Morehouse School of Medicine. So that's a really great question. One of the things that we do is exposure and access. We build into the curriculum things around health equity and what that looks like. So their projects are certainly geared towards looking at health equity, looking at data from the African American communities or the minority communities. And so that when their projects they're doing their projects, they are doing projects really based on this community so that they can engage with the community, that they see the data, they understand the data, they compare the data to see what happens in other communities so that they're aware of and they see and understand what the differences are. Oftentimes we look and know and hear, but until we actually touch and feel and see, then it's difficult for students to understand. But we are certainly aware of all of the issues around health equity. That is what we bleed. And so each of our courses, if you look at our curriculum map, we have a section even in our curriculum mapping where we outline specifically that there must be some type of project that is built around health equity.
Great. Thank you so very much. Dr. Brown, you mentioned that you have an advisory board for your data science and analytics program at Bowie State. And from the looks of your advisory board, and I'll put the link in the chat in a second, you have a wide range of people and expertise. How do you choose who should be on your advisory board? And what was that process of forming it? And in particular, for advice of those who are kind of new to this, establishing advisory board of industry folks and interacting in the academic space, what are some strategies you have? That's a lot of questions in one.
Yeah, so I was actually new to forming an advisory board as well. And I knew it was important with data science and analytics to really have people like Dr. Howard was saying that are competent within the fields. So I love LinkedIn. So I utilized a lot of my resources and contacts through LinkedIn. I also looked at the organizations that I wanted my students to intern with, like PricewaterhouseCoopers. I wanted my students to intern with them. I also looked at organizations where my students we were using their software programs like IBM and so forth. So we went to them and asked them for partnerships as well as for them to be a part of our advisory board. We, one other thing was that people, you'll notice that when you go to people, they're really open to help. They want to be a part of this process. They want to be a part of shaping the next generation of people within this career. So that really helped to just understand that they're open to it. So it's not an issue of, you know, burdening them with wanting to be a part of your advisory board. This is something that they definitely want to do. Another thing that was important was when we couldn't meet face-to-face, we used technology. We use things like Slack, social media, and I was always sending out things about what we were doing, and I was getting that feedback. And so definitely pull on your inner circle, but then go out into your outer circle as well as your circle that hasn't even existed yet, and just know that people are willing and they are excited when it comes to helping the next generation.
Great advice. I've made a lot of good connections on LinkedIn. It's amazing. It's great. Thank you. So Dr. Hussain, you talked about using already existing courses to build up the major. Somebody has a question that, you know, they say they understand that data science involves computer science, math, and statistics, but sometimes it involves students from other fields, biology, sociology, political science, and so on. And they want to gain data and statistical literacy. So do you ask like the comp sci math and stat faculty to flag their classes to denote which are of interest to students who want to learn data science? Or how do you do that delineation so you can communicate to students that these are the courses that have data science in them? And then how do you kind of look and assess those courses to determine that they have perhaps enough data science flavoring in them?
Sure. Thank you for asking this question. At Fisk, we did another very interesting initiative, which is computational thinking for student success, where every incoming student will take a basic programming course, in simple word, data basic course. Some students take in the fall semester, some in the spring semester, and hopefully it will be part of our upcoming proposed QEP plan. So whole institution is after it. It's a big initiative. So that is the first thing, that all students get the taste of what actual basic coding or programming is. So it's not quite like a distant entity for them. They get the first-hand experience, but they don't become software engineer after one course, but they get the taste of it. Can I pursue further? Second thing is, we also, as you can see in our major, we have the third partner discipline component. We really want students from biology, physics, psychology, political science. So that is there. So many students who are already in biochem or psychology, sociology, they take, okay, I have already taken my own courses, I can extend it further towards data science as well. So I think that is to reduce the phobia that I cannot do it. You know, I can do it. It's not so challenging. You know, President Obama mentioned in his famous YouTube, don't just use the app, don't just play it, program it. So it is for all of our students that we need to learn how to program it. Also, there was a question regarding funding. I have a chance, I can answer that question as well. So Fisk, we did not get actually funding to launch the data science program. We went the other way around. We already have other NSF proposals for curriculum innovation. So we already had the courses, and that we say it is the best way. Why don't we launch this initiative? We went all the way, proposed. Once data science was approved and we start offering it, then we get actually more funds and money. Money will start pouring in. Students showed interest, administration showed interest, easy to get more funding. So we did not wait for funding to arrive. We start working on it because we knew this is just like, you know, you buy stocks, you know, it will go high. It's a good stock. There's a good time to buy now. It will grow in the future. So we strongly believe it. Data science is exciting, major. It will grow further. So I will recommend colleagues, don't wait for funding to arrive. start working on it right away, and you will get the funding. And it will actually even help in getting the funding that you have done some prior work already.
Great advice. That's great advice. I put a link to the TIP program for it's HBCU undergraduate program at NSF in the chat to see that. Our friends at Norfolk State, which is HBCU in Virginia, they are starting a master's program in data science. So they're starting out from zero. Dr. Howard, as they're looking at the landscape, what are some of the first things that they should be aware of? Because y'all are number one, right, in the biotechnology. So they want to know, speaking for them, how do they get to be number one? Because sometimes that start can go in a wrong direction. How do they start and go in the right direction?
Advisory board is very, very key. We've said it a lot today, but the reason why it's key because they are the external people that see what sometimes we don't see because we're focused internally on what's going on. We're focused on enrollment. We're focused on retention. We're focused on student evaluation, faculty evaluation. So getting a champion of team externally, but then also getting a champion or buy-in team on the inside as well, preparing your faculty, making sure that they understand what is to take place, understand why it's important, and that they are on board. You want people who are going to champion everything that you do, or at least champion the start, so that you can avoid as many roadblocks, as many barriers as you possibly can. And then making sure, I'm going to say this, that your social media team or your marketing team, that they have some good stuff that's going out there so that people can know what you're doing, people can see what you're doing. And then that you are making sure that you are connecting with the students, because guess what? The students are your mouthpiece. They're your biggest. They can be really, really good for you, or they can be really, really bad, because everybody goes and do this. They pick up their phone and start typing and chatting. Before they know it, it's out there. So making sure that you have great external people who are supporting you, who are championing you, making sure that people are on the inside, your faculty, you are engaging with them, they have buy-in, so they're seeing what's taking place, they're seeing it unfold, helping it to unfold, and then making sure that you have strategically aligned the mission and the curriculum, so that at the end of the day, when students are leaving, they have opportunities, their jobs, they have scholarships available, and that what you're creating is going to be, even again, as Dr. Brown said, the first people she look at are places she wants her students to go. So when they leave, they have a place to go and be successful.
I like how you're saying that, create the program that really speaks to the mission of the institution, because I find that since data science is so new, it doesn't have a home specific department. So it's not like data science falls into the mission of a department. It's so, I don't want to say easy, but I'll say fun to actually take the data science mission and have it speak directly to the mission of the institution. Because I see at least our program, minor program, is an institutional data science minor that engages all the disciplines, not in the department, but we actually look at, in this case, multiple institutions' missions, the collaborative. So that's great. Dr. Brown, with your data analytics initiative, you all created DSA modules: Introduction to Data Science, Big Data, Modeling, Management, Technology, Data Analytics, Visualization and Visual Analytics, Data Mining, Machine Learning. Love machine learning. What are these modules? How did you make them? How did you engage others in making them? Can you tell us a little bit more about those modules?
Okay, great. We started off, before we even created our modules, it was important to really have faculty development. Like Dr. Hussein was saying, is that your faculty members, they might not have had access or familiarity with the new programs and so forth. So it was really important, and that we utilized some training. So we kind of went the inexpensive route and used IBM cognitive classes. So we designed which modules aligned with the courses on IBM Cognitive class. Then we had the faculty members just go there and take some of the courses, and then we came together within our faculty learning communities, and then we as a group, we established what our learning outcomes were for these modules. Then after we established our learning outcomes, we began to develop different types of material as well as develop rubrics. The beautiful thing that I really like about our modules is that it's not just a module that you can, it's not a cookie cutter module, but the faculty members, based upon their discipline, they have to go out and identify a data set and a problem and a question that's going to be aligned to that module. So the students get some familiarity with some of the key data science concepts or data analytics concepts, and then they're posed with a problem and a question as well as a database, and then they begin to utilize the program to do different types of data analytics and understanding the whole concept of data cleaning and so forth. Now, I think you asked how we got the faculty members involved within this process. I'm an economist, so I believe that financial incentives are important. So we offer very small, the grant helped with that. We offered really small monetary modules, but it wasn't just a monetary payment that was just in the beginning. We made sure that, okay, you get this part, you know, being a part of here, and then after you produce this and show how you've been working with your students and provide us some data, then we'll give you the other half of your honorarium and so forth. So that's how we really incentivize faculty members in the beginning, but now, like I said, it's just more of a family and a safe space. It's very important. Let me say this: it's very important from the beginning to make sure your faculty members have a safe space where they can say, I don't know something, okay, but I want to learn. And so that's very important for you to have that, and I think that you'll get a lot of buy-in with developing the whole process.
That's great. Thank you so much. And I think I've heard the bells toll outside my window here in Atlanta, Georgia. So Dr. Brown, Dr. Hussein, Dr. Howard, thank you so much for sharing your perspectives on how to build data science programs. You all have amazing programs at phenomenal institutions, and we look forward to continuing conversations and see where all of this goes. So as they say, go ye forth and build up the data science programs to create more opportunities for our students. Thanks again.
Thank
you very much.
Thank you so much. Bye-bye.